Let's have a look at practice question set number 3 here. We start off in a predictable way. We see a force versus time graph, and there are 3 words that you should think of when we see this force versus time graph. Jacob, what are they?
Area equals impulse.
Area equals impulse. Good. Now, whether we have a force time graph or any other graph, the next thing we should do is look at our axes. In this case, we have on our x-axis seconds. That's good. That's standard. But we also have on a y-axis 10 to the 2 newtons. We want to circle that, draw attention to that, because that's something that could lead me to pretty easily to a silly mistake here. Question number 1 says the area under the curve represents. We already answered that. Jacob already said area equals impulse. So the answer for that one would be B. Number 2 actually asks us to find the impulse, but, oh, you have to be so careful here that you don't miss something. What is it that we got to watch out for in question 2? Like, it seems straightforward. You want to find the impulse? Find the area. Watch out for the units, right? What else? What else is going to lead some of us to a mistake here? Yep. Yeah, the time didn't start at 0. We're talking about from 2 seconds to 5 seconds. So what we want to do is find only these 2 areas. That make sense? Notice on the back wall, I have this big letters RTQ, ATQ in red boxed off there. What do you think RTQ stands for?
Read the question.
Read the question. ATQ stands for answer the question. Okay, read the question. This is an easy question. If you just read the question and then answer that question. Don't answer some other question. Don't find the impulse from the start. Find the impulse from 2 seconds to 5 seconds here. RTQ, ATQ. All right, let's go about doing this now. Let's say area 1 is base times height. Be careful. The base is 2 seconds. The height is 20. What is 20 times 10 to the 2? Just tack a 10 to the 2 onto the end of that 20. That gives us, I believe it's 4,000 Newton seconds. Area 2 is 1/2 base times height, because triangle, it's a right angle triangle, but that doesn't really matter. The base is 1. The height is, once again, 20, but we can't forget the times 10 to the 2. That's going to give me, I think it's 1,000. Is it 1,000? What's the total area there? From 2 seconds to 5 seconds, we add those up, and we get 5,000. If that line was below the x-axis, what would we have to do? Yeah, make it negative. All right, let's take a look at the next one. I think it's the last one. Yep. A group of students performs an experiment to explore a non-uniform accelerated motion in which the magnitude of the force increases as a function of time. The mass of the low friction current is 0.50 kilograms. Oh, look. What do we see? A force versus time graph. 3 words. JC, what are the 3 words? Force versus time graph. 3 words should come to our mind. Good. Area equals impulse. All right, what's the next thing we do? Every time we see a graph, regardless of whether it's force, time, or any other graph. Davis, what should we do here now? Yeah, make sure your units are standard units. If they're not, then draw attention to it, right? Here we have on our x-axis 10 to the minus 1, okay, non-standard, and on the y-axis also 10 to the minus 1. So we want to draw attention to those so that we don't make a mistake when we go to sub our numbers into some equation. All right, what are we looking for here? We are looking for the final velocity. Okay, the final velocity. First thing we're going to do, same as always, find the area. The area is 1/2 base times height. The base is 8 times 10 to the minus 1 seconds. Is that right? And the height is 3.123, 3.4. Is that right? What's wrong? No, exactly. It doesn't start at 0. It's a good observation. It starts at, be careful here, 0.5. So Jacob, then what's my base?
7.5.
Good. 7.5 times 10 to the minus 1. Now I'm going to calculate that area. It is not my final answer, but it is does put me well on the way to the final answer there. The area of that is 0.1275. Now I'm going to say delta P is equal to m times delta V. You see how they're all pretty much the same? Like sometimes we get 10 to the minus 1 newtons. Sometimes they might have something below the x-axis, whatever, but they're pretty much the same. The odds of seeing something like this down the road are I would suggest, very, very high. 0.1275 divided by the mass. The mass was 0.50. Delta V is 2.6 times 10 to the minus 1 meters per second. How do we express that? As ABC.
2, 6.
No, 261 blank. Okay, 261 blank. We're only asked to fill in the digits 261. We don't fill in a decimal. Okay, it's just the digits A, B, and C. Now, sometimes you may be asked a question like this, where you're asked to express your answer not as A decimal B times 10 to the minus C, but rather B times 10 to the negative W. What's the value of B? This is different. Okay, B is a base now. 2.6 times 10 to the minus 1 is still my answer. But the base here, the base is what? 2.6. See the two different ways of expressing that? Pay attention to which way you're asked, read it, and answer it. For the next month or so, if you have trouble answering one of these questions in terms of how to fill it in, just ask me. I'll help you out with that. Even on a test, I'll help you out with it. But over the next month, we got to start figuring that out so you're able to do that yourself, okay? Say in another month and a half or so.